Hey, this is learning target number 1. You need to learn how to factor. And there are 3 different kinds of factoring that we got to talk about here. The first 2 are going to be very easy to do because they're actually special formats. But the last one's going to be a little bit more work. First of all, what is factoring? Factoring is turning an expression that likely has an x squared in it. It could have a higher exponent in later maths, but for right now, we're just doing the squared versions. We're going to turn it into expressions that have things that are multiplied together. Factors are anything that's multiplied together. So what we're going to do is this. In number 1, there's a special format, and it's actually the easiest kind of factoring there is because we have 2 perfect squares with a minus sign in the middle. This is called difference of 2 squares. Difference because there's the minus sign, squares because they're perfect squares. And all we're going to do is square root each of these 2 terms. X squared, square roots into just x, and 100 square roots into 10. And so our factors, we instantly write these down. X minus 10, because those are the 2 square roots, and the other factor has a plus sign. Easy as can be. That's really not going to be too hard. Just square root both the things. Number 2 is also kind of easy because all we've got to do is find a GCF. And I know that we're just going to pull a GCF out of this because both of the terms have an x. And there's no term at the ends like the other examples have. That's just a regular number. So looking at the GCF, 2 and 12 are both even numbers. So I'm assuming 2 is part of that GCF. And they both have x. So your GCF is 2x. And we're going to pull the GCF out of this expression. And that leaves behind x as the first term and 6 as the second term. And this is completely factored. This is 2 things that are multiplied together. The third example is a little bit more difficult because to factor this, we're going to have to use the very long factoring process we talked about in class. That looks like this. So first up, because we've got the 3 terms, this is not a special case. We got to do the full thing. And I'm also seeing there's not really a GCF here. Like 2 is an even number and it's not going to be a factor of 15 or of 27. So there's no GCF we've got to worry about here. I'm just going to go ahead and instantly write down, we want to write down that A is equal to 2. B is equal to negative 15. And C is equal to negative 27. This is the A, B, and C that we're going to use for our big factoring process. And it looks like this. The first step is that we want to multiply A times C. That's going to be 2 times negative 27. That's going to be a pretty big number, actually. Equals negative 54. And from this negative 54, we've got to find 2 things that multiply together to make negative 54 and also add together to create the B value, which is negative 15. And that's not super easy to do. So I'm going to cheat a little bit and I'm going to use Desmos. And because we have 2 things that we'd like to multiply together to make negative 54, I'm going to create a system of equations. We know that x times y, the x and y are just mystery numbers. We know that they're supposed to multiply together to equal negative 54. The other thing is, and by the way, it creates kind of a, if you're in Algebra 1, you probably haven't seen these before. That's okay for now. We also know that adding x and y, our mystery numbers, together has to equal that b value, which was negative 15. And you'll notice it creates 2 intersections in Desmos. The intersections are located at negative 18, 3, or 3, negative 18. Doesn't matter which you choose. The order does not matter at all. But that reveals to us what those 2 things are. Negative 18 and 3. They add together to make negative 15, and they multiply together to make negative 54. So what we're going to do is this. We're going to jump into the box. We're going to make a 2 by 2 box. And inside of this box, I'm going to put 2x squared because that was in the original equation. I'm going to put negative 18x. That's result of that last step that we did. I'm going to put 3x, likewise. It's from the split of negative 54. And then I'm going to put the minus 27 that concluded our equation from before. Then I've got to find the GCF of all of these things. The top row's GCF is 2x, so I write that on the side. In the bottom row, GCF is 3. I know that because 27 is divisible by 3. Then the top column, all they have is x right here. 2x squared has an x, 3x has an x, but those numbers don't play nice. It's a 2 and a 3. They're both prime numbers, so they're not going to actually have a GCF of the number parts other than just 1. And the right-hand column, negative 18x and negative 27, they actually have 9 in common, and I'm going to make it a negative 9 because as I'm reading downwards, I see negative signs in front of both of those things. And well, it turns out that these two GCFs are actually the answer to your problem. They are the factors, the things that are multiplied together. So all you do here is just write out your answer. And there you go. Factors, two things multiplied together. Hope you found it useful.